So a couple of questions about your Cashbench. So I want to know if it's open source, it's available to public, and also to measure CXL, why you choose cache. I mean, you can do like FIO style, check the bandwidth and performance. Why you pick the cache to measure the CXL DRAM?
Okay, okay. Yeah, excellent question. Let me answer the first one. Cashbench. Uh, yeah, so Cashbench is open source. I think Manoj actually talked about that in the morning. This is actually Facebook contributed open source project. CacheLib is really the foundation. Cashbench is really the benchmarking tool on top of that. And it has different types of profiles too. So if you look at the Cashbench, so it's open source, you can actually try it out. Now, why can't you use FIO? You can use FIO. The only thing is that you won't be able to test the tiering aspect, right? So technically you can use FIO, but it's not really optimized for memory load store type of transactions. You probably need to enhance a little bit. But yeah, you can use FIO too. Nothing wrong in using it. There is a PMEM driver with FIO. You can actually use that too. That actually uses the DAX extensions to it. But yeah, you can use FIO as well.
Okay, yeah, let's go ahead with the next question.
Just one second. Just wanted to remind everybody in the room, Alex is on the call as well. So if you have questions for AMD, please do ask and we'll teleconference Alex in.
Why don't we go to the guy on the right here?
My question is to Samir about page migration using DMA style data mover. Do you think it makes sense given the amount of latency it takes to set up the DMA? I mean, is it really, especially for small pages, does that make sense?
Yeah, that's a great question. We did a lot of timing analysis on DMA, Prakash, as you're aware. And yes, that is why we need, DMA is not the only solution, Prakash. At some points, the software plane may choose to use memcopy. And at other times, it may choose, when you're doing 2 megabyte page migrations and breaking them up, that is where DMA could potentially be useful. But at other times, when there is serious contention, you might just take the 2 megabyte page and chop it up into 20 pages and then just use memcopy depending on what your utilization is. Yes, Prakash, I can see where you're going, and it is not a silver bullet. Ready?
Thanks.
No, I don't.
So let's go over to the left-hand side.
Yeah, this is 2 quick questions. So I saw some very fascinating hardware, CLX memory on a DIMM. Is that like prototype, or is that going to be available very soon, and from whom? And then the second follow-up would be, I also saw the EDSF E.3 from Samsung, which was another CXL product. Is that in prototype? And, you know, it's just very, very exciting to see that.
Okay, so let me cover the demo that I showed with the CXL memory buffer. That's based on the Intel FPGA pre-production chip. But there is a plan to make it available through something called DevKit once the FPGA chip actually goes into production. There is a plan with FPGA-based solutions, primarily for POCs and acceleration type of capability where you need not just the memory, but some sort of acceleration using FPGA is a good candidate for that.
Thank you.
Hello? Yeah, we haven't announced our sampling schedule, but we are working to sample.
Will you be able to see any demo of that on the floor, or can't say right yet?
I'm not sure what they're preparing to demo. I believe they are. So what we have right now is a functional sample, a pre-production functional sample. It's not the actual device. It's also an FPGA-based prototype. I'm not sure they will be doing the demo with the actual hardware. Okay, yeah, okay.
Awesome. Thank you so much. Very exciting. Great work there.
Thank you.
Hey, it's more a question, I guess, for Reddy. So you can have type 3 devices that are not percent memories, that are not either DDR memories that you want to be registered as regular memory, but are kind of a weird accelerator devices. So like, you know, like the UEFI map where you have special purposes, it might not scale from an operating system point of view to only have like this binary decision, are you DAX or not DAX? Because it can be much more like and I expect it's going to grow actually with the more media coming up to the market. I expect we're going to have more kind of devices that don't want to be registered themselves as regular memory from the kernel point of view.
So the question is, can you have different types of CXL buffers?
You can. I know you
and
can, but
expose them as kernel,
Yeah.
have flexibility in the same platform to manage that as the kernel memory and DAX based on needs?
So
the
like
same
I'm
time?
kind of like pointing out to the fact that the UEFI memory map
Right.
with just 1 bit for a flag is kind of a real limiting factor for them to have the operating system decide what to do with the memory based on just 1 bit, you know, like percent memory or not percent memory,
Right.
where it can be a much wider range of things, where it can be an accelerator that has memory but don't want it to be managed by the kernel but by a device driver, or it can be something else that I cannot think of right now.
Yeah. So if it is a type 2, so first and foremost, if the device does not want to expose that, then it's not called host managed device memory. So there is a type 2 device, and type 2 device has to make a choice whether it wants to expose that to the kernel.
But
Then the firmware flows will kick in.
Yeah, but like one of the issue of type 2 device is that you need to have CXL.cache. And some devices don't want to have CXL.cache because of limitation of the platform nowadays.
Right. Yeah, you want flexibility of whether to show it up as a kernel versus DAX, even for type 2. You can, based on the firmware support. You can mix and match. I'm not suggesting it's one way, where if it is type 2, it always behaves like a type 2 managed by kernel. You can pick and choose the best possible way to expose that to the operating system through the firmware configuration knobs.
Okay, thank you.
Yeah, on the Samsung presentation, when the CXL was being presented, and there was mention of type 3 versus type 2, and you said type 2 appears to be the future. I'm trying to understand that statement in regards to memory expansion.
No, I think you misunderstood. What I said was in reference to the earlier presentation I had made on processing in memory and processing near memory. What I was suggesting is that that work may well move over to CXL depending on the market request, if you will, right? So I think that the CXL is just a much nicer interface to do this work on than the DIM interface. That's what I was trying to go.
Hi, I have a question on.
Go ahead.
I have a question on the reliability aspect. Someone covered about the reliability. When you are directly connected to a host processing system, you have less number of hops, and so the reliability is better, the latency performance is better. But when you move to the serial attached, you have number of hops, both for a bridge converting from a CXL to a memory domain. How do you see that affecting the reliability of memory access? Because for memory applications, reliability is far more important than the storage needs. Do you see a problem there, or the challenges there?
So you're talking about the CXL memory buffer. The DRAM modules are DIMMs attached to the CXL memory buffer reliability versus the host DRAM reliability. Is that the one you're referring to?
Yes. If you were
Yeah,
a
okay.
DRAM connected to a DIMM versus a DRAM connected to a EDSFF memory module, so
Yeah, I mean, I personally don't see the reliability delta between those two. So we have been internally within Intel, we had a lot of debate about, is host DRAM more reliable than the CXL memory buffer? But if you look at, obviously you have a CXL controller in the middle, right? As really as additional bump in the wire type of, reliability attribute. But if you look at NVMe SSDs, NVMe controller has been there forever. PCIe fabric has been there for a long time. So the fact that the PCIe is fairly reliable, right, highly reliable rather, with the NVMe controller being highly reliable in the industry, because these SSDs have been there for a long time, we don't see CXL memory buffer being less reliable than the host DRAM modules. Historically, that's, you have the fabric reliability, you have the controller reliability. We believe both those things can be addressed.
Thank
you. What Samir talked about is definitely near and dear to me, the hardware page migration, TLB management, non-blocking. But all the way on the other side, a lot of the discussion today has been around that. All the way on the other side toward the very extremely app aware. We haven't heard much today about being able to pin pages into one particular tier, even give compiler hints, or for initial page location, or even biasing toward weights for where pages potentially can go. Is there much discussion of that, potentially even hardware support that is being talked about right now?
Yeah, so I'm not. I really can't talk about the hardware implementation, but the pinning aspect and the policies on how you move the data back and forth between hot and cold, there has been a lot of discussions, right? So CacheLib, as an example, there are a bunch of policies you can actually set. So the policies could be, I want, let's say, 512 byte or 4 kilobytes go into the lower tier than actually the smaller ones going into the higher performing tier. So you can actually construct a set of policies by which you are going to allocate initially, as well as move the data back and forth among the tiers, right? So you have that flexibility through the software constructs. And that implementations do exist in the CacheLib as an example. Kernel tiering, especially within the context of Linux kernel tiering, I believe there is work needed, right? It is still fairly very early in the implementation. There are a couple of things where it evicts when there is actually a pressure on the host DRAM tier back into the lower tier, but how do you promote them? And do you want to actually have certain pinning policies so that you don't evict at all? What kind of policies you should construct for the tiering to be effective? Those things within the context of Linux kernel still requires a lot of work.
I'd like to add to that. Yeah, and I just needed with Reddy's commentary, I was just thinking through it. I think it's a positively great question. So at least internally, we are looking at two models for app-aware memory tiering. The first one is as Reddy showed, with clear examples how the the memory tiers are completely explicit to the app. But we think that is also there are big entities that can do that with a lot of intelligence in the organization. But then there is also the problem that most of the app developers could not care and could care less about what is the underlying infrastructure, right? So, but while making it OS aware or hypervisor aware requires broad orchestration, which many of the enterprises don't have that ability. So there is another middle level there, Rob, that we have investigated and released open source just along the lines that Dr. Wong talked about, which is runtimes. And the runtimes can be built without app modifications, but the runtimes are intelligent enough to be able to disambiguate the various tiers, right? Correct, more clearly. And so that is another approach that one is looking at very carefully. And so there is the runtime approach as opposed to the app approach itself.
So this is the last question. Okay. So the last question is about page migration. Like, there is a lot of assumption that page migration must be tied to the kernel making the decision of what to migrate, when to migrate. But you can actually provide the API to the application and get out of the kernel get out of the way, and so that the kernel doesn't have to care about coldness and hotness detection, and it's all up to the application. So instead of having like this application API where you fix the allocation to one type of memory, you have like this page migration API where you allow the application to migrate things back and forth between different kind of memory over the application lifetime.
Yeah, very well said, right? So I mean, I do a lot of software development. I hate to actually write software primarily to instrument all the policies in my software application. I would rather actually take advantage of transparent tiering. It may not be perfect, but it's good enough for me not to reinvent that. So in general, anything that is transparent, good enough, is likely going to scale much more broader than actually doing some hand stitching.
Yeah, no, I'm not saying you should not do the kernel clever thing with your stick to try to move things around as best as it can. But some application, they know exactly what's going to be out in the next minutes because, you know, I'm training a model, so I'm going to train on this image, and this image. So I'm like, put all these images out. Once I'm done training on these images, you can move them back to some coolness, and I'm going to go to the next batch of images.
Yeah.
And then because, like, you know, training, you cycle again. So like what was cold might become hot again. So like some application, they can really benefit from like being the orchestrator of the iteration instead of
exactly. But see, if there are like machine learning and deep learning frameworks where there is a certain pattern, let's say in MapReduce, if there is a certain pattern where you can actually track and manage the page movement very effectively, sure, you can do that, right, through the frameworks. But you know, if there are specific set of applications that really require very hand stitching tiered implementation, you can always do that too. But that profile of apps is probably going to be very low compared to mainstream apps where software developers don't want to go do that.
Yeah, thank you.
Well, thank you to the panel.